Yeah, okay, Coffee Compiler Club. There's just four of us right now. Maybe more shows up, maybe not. So I have a rant that I'm going to rant this morning, and it's chapter 18 functions on simple. And it was intended to be easy, cheesy, peasy, and it started off life that way. And then I discovered that I need to call main and have main return, which is pretty reasonable. Every other language on the planet starts by calling main, except I had not started that way because as a tutorial, I just wanted to write some code and run it, write some code and run it. And so all tests up through chapter 17, all 280, they just expect an answer to come back at at the end of the world, and there's no function calls involved. And now there is a function call. So every single test on the planet broke looking for an answer and finding a return that contained the answer instead of the answer. So I had to figure out a way to go deal with that and get all 280 odd tests to not just break stupidly. I mean, for no good reason, right? The tests don't test this, they don't care. So that was that. And then I was trying to get some function call evaluation. So after chapter 10 or 12 or something, we had an evaluator put in by Zmilia. Real name might be Nick. And it was a great thing, and you could watch programs run, and that's fantastic for learning and whatever. And I had trouble extending it to do function calls, and especially recursive, but in general, just function calls. We're not doing it. Anytime I had a function that was called twice, even not recursively, just you called it once, you called it again, it was busting. Okay, so I had to go back through and figure out what was going on there. I couldn't do it. And that evaluator like did its own version of scheduling and had a bunch of other things it was doing that was kind of overkill and difficult to go to modify. So I wrote another evaluator that relied on local scheduling. Well, I already have a global scheduler. If I had a local scheduler, then I basically have idealized machine ops in the sea of nodes IR. It's just machine ops with a funny machine and an infinite register set. And I'm executing like you're interpreting x86 bytecodes or Java bytecodes. This is like the stupidest execution strategy on the planet. Um, but to do that, I had to write an evaluator. And the evaluator needed a local schedule. Well, the evaluator wasn't too bad. That was, a couple days to a week, followed by I needed a local schedule. Again, not too bad. But the prior evaluator did its own scheduling. It didn't need a scheduler. And so it was just called willy-nilly from the tests. And the new evaluator needs the scheduling. And in fact, it doesn't work if you have broken programs. And the old evaluator sometimes did and sometimes crashed if you handed it just broken programs. So you need the type checker. So at this point, I need a compile driver that demands that you run the optimizer to clean out dead control flow, which the new evaluator does not handle dead control flow. And then you need to run the type checker, and then you need to run the global and local scheduler, and then the new evaluator runs, and it runs faster than the old one. It's way simpler and way smoother, and doesn't do a lot of extra stuff because it doesn't have to anymore. And it looks clean and simple, and it's all great and wonderful, except that this has nothing to do with functions. This has, I didn't have a compile driver, now I do. I didn't have a call to main and a return, now I do. And there was a third giant thing that had to go through. Types went through with function pointer types. That one went smoothly. I guess I kind of knew that was coming. And then sort of the least of things was the actual, here is a function call, and here's a function, and here's a call to a function. Um, Most of the last of chapter 18 is tied up in reevaluating, redoing the tests, inserting the top and the end of the world, the beginning, the start, and the end of the world with a main call to main and a return, the new evaluator and the new local scheduler. Um, Somewhere along the line, because it was fun, I threw in the JavaScript viewer, although that has nothing to do with function calls either, other than it was very much fun to look at. I don't know if it's usable in the long run. I have used it to debug once or twice because it's kind of a quick way to get a sense of where something went sour, exactly what went wrong. But as a large or as a general purpose debugging tool, it's probably not it. So anyhow, that rant brought to you by a project that should have been a week tops that turned into a month and a half. What did I do on my Christmas vacation? Well, I rewrote all kinds of stuff in order to do functions, and the functions themselves were the tiniest thing.
Yeah, it reminds me so much of that saying, You get 90% done, and then you have to do the other
Then
90%.
the other 90%, right? It's all working and great. Oh, I want to add a function call notion. Well, okay, every other thing on the planet has to be reshuffled, and now function calls can come in. But every other thing is the other 90%. There it is. Uh, so for people who rove late, the too long didn't read was I didn't have function calls. No one calls main and returns. Every test on the planet broke when you added function calls because they expected an answer, not a return containing the answer.
This is in the simple
In the
project
simple
that Cliff is
project,
working on.
yeah. And then I needed a new evaluator that could handle function calls. And that means I needed global local scheduling. And then I needed a compile driver so the evaluator would get things that were scheduled because the prior evaluator did its own scheduling job, was one of the reasons I couldn't add functions to it. And one thing led to another. For one of a nail, the kingdom was lost kind of thing. Um, Rant done. Chapter 18 is in. I'm waiting for anyone else who wants to throw in any code reviews. If you want a code review, you're welcome. But it's done. And there are many thousand things that would be fun to go do that are just begging, like method calls or inlining heuristics other than the dumbest on the planet or anything. Thousand things could be done here. I can build a call graph. I, in fact, know exactly how to build a call graph. I could run the global SCCP that would give me a call graph just straight up. I'm
That'd
going
be
to
an
do
interesting
CodeGen next.
chapter 19.
Yeah, chapter 19 is going to be CodeGen.
So,
CodeGen.
you've got a couple other people kind of porting this to other languages as well while you're building it, right?
Yeah. Yes.
So, um, I know that Tommy or Tommel or whatever his name is
Tommy on,
C++.
yeah. Yeah.
Is he learning C++ as he's doing this, or he's already?
So at least one of the people working on one of these ports seems like a senior engineer and went straight at it and had all trouble expressing Rust and how Java was doing things because Rust and pointers and Java pointers don't cross very well, apparently. And Tommy did not have that problem, but he had sort of naive a few naive C++ problems and a few didn't understand what Java was doing problems. So I think he's learning C++. He's like a junior engineer style guy. Um, he's clearly learning a lot of things in both directions. And then he says things that have jargon. Like he brought up virtual inheritance, which is a magical C++ thing, as opposed to virtual function calls, which Java and C++ both happily do and everyone understands and loves. And that triggered, I want to say, triggered Matt into thinking, me too, Matt. He was doing virtual inheritance. I was like, twitch,
Multiple,
what?
which multiple inheritance stuff.
Right, some multiple inheritance things. Like, no, no, you don't have to do that. Then it turns out he's just, misusing the jargon word. Okay, fine. So wasn't that kind of mistake, but it was a jargon mistake, which tells me
Yeah,
maybe he's
pure.
a
I
no
think what he
coding.
meant to say was pure virtual classes, right?
Um, maybe. I don't know if he's all pure virtual classes.
Well,
Simple in Java has
he's got the virtual keyword in the equals zero, which is how we did pure virtual 30 years ago. So
okay,
Matt,
yeah. I mean, I don't know if he's got it everywhere though. Like in
ah,
the simple project, the base node class is abstract, is a virtual class. But like regions inherit directly from node. That's great. Loops are a version of regions that have exactly two inputs and the other one's a back edge. So they're a subclass of regions. So region's not pure in that sense. There are a couple other places where that shows up. So the project doesn't, as the Java side, is not just all pure virtual or not, but the main ones are virtual.
well, the main thing is that Java is pretty much pure virtual through and through because the decision of which piece of code to call is always made as if it were made at runtime.
Is it? Yeah.
Where in C++, virtual classes, the decision's made at compile time.
Yes.
Only pure virtual is made
And
at
yeah,
runtime.
you throw a keyword down.
But you have to do the virtual, plus you have to do the equals zero.
Oh, if you're going to do it virtually that way, no, you can get virtual calls that you override. You don't have to have an
You
equal.
can override them, but the decision of what to call is made based on the compile time type.
No, no.
Matt, correct me if I'm wrong here.
No, no, it is based on runtime.
Yeah.
You only do zero if you do not want to any implementation in the base class,
Right.
but you do virtual whenever you want to have runtime dispatch. virtual means runtime dispatch, always.
Yeah.
It can be optimized to compile time if the derived class is known at compile time. But if it's not known, like if you have a container of base pointers, then it's going to be called through the virtual table.
Okay, so the virtual means to the vtable call.
Yeah.
Yes.
Yeah. Use a vtable. Yeah.
Okay,
It's exactly, I mean,
it's been too long. I haven't written classes in C++ since Java came out.
there you go. I mean, my C++ and the Java implementation of simple are almost identical in how that piece of it is structured. They're really close.
So the nice thing about Java is after Java came out, I could use C instead of C++. Because
Yeah. Yeah.
anything that needed classes, I just use Java or C# for.
Ah, so unrelated, anything to do with compilers. My wife's been fighting her failing knee for the last several years. There's no long-term goodness here. There's going to be knee replacement at some point down the road. But she's got a new improved medial offset brace coming in a week. And I'm hoping she can walk around the house after that brace without yelling every other step, the knee hurting. It's been bad. And she's been doing an elimination diet, and it's been working. She knows now that she can't eat corn or mature corn. Baby corn is okay. Canned baby corn is okay. A bunch of things are funny, okay. Sorbitol is in all mature corn. Can't have that. And there's a bunch of other things. So that's like working out. And I've been in trouble getting my car past smog because CARB basically changed the rules on me after I modified my car's exhaust. And I finally found a guy who can give me an official CARB approved exhaust with pretty minimal cost, actually. He's going to cut the old piece out and put a new one in. It'll have a free CARB sticker attached to it. And that will be the end of my long, painful, can't get my car through smog because it flags as tampered exhaust. Fine.
I see your wife has a bad knee and car stuff. And raise you why my wife got mugged and they stole her car keys.
Did you lose your car too? I mean, did she get beat up?
She didn't get beat up and she didn't hurt anyone, which was very important because she had the capability to, but didn't. Very proud of her on that one. But yeah, they took her car keys, looked at the car, like they knew which car was hers because they'd just seen her walk out of it, and decided not to steal the car. So yay!
Why'd they take the car keys then? What the hell? Fine.
Because they took everything she had, just all the things. Like I'm glad
Right.
she got to keep her sweater at least. So
I mean, when my last time my car got broken into, and then no keys were involved, they just crowbarred
yeah.
and window was gone and they
Unfortunately, they
grabbed and ran
stole
it.
her. Unfortunately, they stole her phone, but they didn't steal her phone. So yeah, so
Okay.
she was okay. So yeah,
Wow. I got
instead stole like a
a
calculator or something.
antique leather bag that my dad took when he went off to war, and monogrammed by my grandmother, rest in peace. That got stolen, and it had nothing in it except a change of clothes and some, laundry and
This
whatever.
can't top when I think one of my family members living in Philadelphia was mugged, and they were carrying their dead cat to like the cat cemetery. That was all that was in the bag. They got their dead cat mugged. Christ! Like,
Okay, all right, fine,
hey,
all right,
they didn't have to pay the fine though to bury
back
it. So
back on track.
So chapter 20 in symbol.
Sorry, what?
Chapter 20 in
Oh,
symbol.
19 will be start of CodeGen.
19.
And Matt was
I'm
asking some weeks ago, what is the decisions you make about what you do with CodeGen and what not? And I'm going to go with what I've been doing, which will exclude some of the more exciting x86 madnesses up front. There'll be a high-level abstract architecture class. It'll have an implementation of an x86. I'll probably add a port directory with an x86 and maybe an ARM if somebody wants to pile in on an ARM side. And an architecture will describe a mapping from simple nodes to some machine nodes. And then I'll have a class of machine nodes that are custom to that guy, and they'll probably directly extend They'll definitely directly extend the node class, and they may directly extend subclasses of the node class, like adds and subtracts.
So you what? Just pick like 32 x86 instructions and do it as if it was a MIPS?
Yes. Yeah. The beginning thing, so there's separate things. There's instruction selection and there's register allocation. For x86 special, the addressing modes are a little weird, but they're only a little weird. And the encoding is an unrelated problem to everybody and is actually really simple to peel off from everybody else. Register allocation is a little tricky to peel off, but it's not hard. It's not obvious to everyone unless you've done a zillion register allocators. Speaking of register allocation, here's Yasser now.
Look, it's the
Hey,
register allocator himself.
right.
What's up?
So, well, we were just talking chapter 19. 18 went in, it has function calls. It's time for CodeGen. 19 is CodeGen. So, in an effort to get away from my wife got mugged and my needs full knee replacement, we're into what can we talk about compilers and what comes after chapter 18? CodeGen. That's 19. Okay, what's CodeGen? So, I'm going to start with some sort of machine architecture file that's abstract, and it will list all the things that I want out of my generic code that'll be custom filled in by those x86 or ARM or RISC or whatever. And then one of those decisions will be how to map from ideal nodes to some x86 variants. And that will come in as probably some variant of a giant ass switch where I'll walk the graph, grab an ideal node and say, oh, you're going to be an x86 that node. It will probably come after global code motion so that I can not take a complicated addressing mode from outside of a loop and drag it into a loop. That decision may or may not happen. That's fine.
So are all the nodes are x86 representable? So I'm assuming they're not.
These are all these simple nodes are sort of trivially representable by all modern hardware as adds, subtract, multiplies, divides, compares, and branches, and things like that. The control flow graph nodes will not port. They will remain as ideal nodes directly. Branches will become almost surely instances of the CFG node in the idealized CFG node so that I can ask questions about branch op, like how do I invert you? So I need in a machine node, I need to invert a branch so that I can do basic block layout. I need a notion of a hard branch, a direct branch. What's the other? There's a third. I want to say there's a third. I don't have it off the top of my head. There's another notion you want in there for branching. For register allocation, you pick a set of register numbers you're going to deal with. You have a large extra set of spills that'll just be on the stack, and you run them all together in a bit set. If you're on a small machine and the bits fit in 64, you're all happy. You declare long as a register mass. For x86, you almost surely need more bits. Sorry, you want to say something, Sean?
Oh, I was just saying this maps really well to WebAssembly, like the simple nodes that would be like a really good, like really simple reference because it's like, hey, you have an ad, you have an ad. Like you have
Yeah, I've been talking to Ben Titzer. Maybe I should say, we'll port WebAssembly, simple on the WebAssembly too.
Yeah, because it's got like just all the basic instructions. You can do fancy SIMD stuff, but like you really don't need to. It's got like 2 adds, 2 multiplies. The addressing mode is you have an offset. That's it.
Right. Standard RISC stuff. Yeah. So the register allocator wants to know a bit mask of registers for every x86 op.
Infinite registers is the issue.
And it adds extra registers on the end for spilling, and that's your infinite register set. It needs to know if you're going to produce multiple kills or multiple registers out. And there's an easy abstract call for doing that sort of stuff. And there's a couple other things the allocator needs to have at a high level. A convenient way to print registers so you can debug yourself and read what they look like and things like that. You want some encoding, printing goodness. You have a separate from an encoding goodness. So printing goodness is just, I hover in the debugger and it gives me the x86 assembly in a readable format with virtual registers or debug registers or actual registers, depending where you are in the pipeline. I saw you looked funny at me, but that's like a super important debugging detail. I stop in the debugger. He has a default two-string print. The default two-string print will be entirely functional. It will not crush, change, or modify the slightest bit of IR. It will do a full fucking scheduling, God knows whatever thing on the planet it has to, and print a reasonable print of the IR at wherever point you're at, the pipe. And this is like the daily driver thing. Like if that's broken, you fix that ahead of every other thing, immediately stop and go fix your print. Once the print works, you can now go debug normal things and you just stop somewhere and say, what happened? And as you're looking in the debugger off on the side window, there is the ASM. You can hover, get a window, throw it in an Emacs buffer to search, staple, fold, mutilate, figure out what's going on, what went wrong. So it's your big picture, everything.
I need
Anyhow,
an IR printer debugger printer. I need like a second debugger on the debugger because just
you're right. There is a thing that says I need to stop and debug my debug printer. And once I have a thing which breaks in the debug printer, I will usually stop and put a two-string call. Like there's levels of easy things. And one of them is I didn't handle all the null cases. There's a null pointer exception getting thrown. If I look in my debug window, instead of sending, oh, this is what your code looks like, it says, oh, null pointer exception. Ah, on the two-string. Okay, fine. Well, if you bring up the evaluation window and you say thing, and it does a two-string on you, and then you say, crash, null pointer exception. So instead, you bring up the bug. I should demo this. And you say dot two-string in the evaluator window. He gives you a stack trace. Now you can look in the debug window, in the stack trace he gives you, and figure out which line in your code threw a null pointer in the debug. And if that didn't work, I throw the two-string in the code and get right back to that location, and now I single step into the two-string and debug what's going on. Things a two-string will do is like, I have a large cyclic graph. If I just print it recursively, I'll run around the cycle endlessly. It'll never print. It'll never end. So it has to have a visit bit. And then if I have duplicates show up, I want to flag them as duplicates because I've cycled. I want to say, here's the full print, and then, oh, I found my duplicate here. So I have a separate duplicate. So you get a bit set for the dupes and a bit set for the visits and a this and a that. And it's complicated and it's big and then you debug it. No, okay, fine. Once it's debugged, life is much better. Fine. What other things in a code gen? So the obvious pattern is you walk the graph once to convert from ideal ops to machine ops. Now you have a wad of machine ops. The machine ops know they understand register allocator calls and encoding calls and debug prints that include their x86's flavor or ARM or WASM flavored or whatever it's going to be. You local schedule. The local schedule means that you probably want to do delays and functional unit counts. I know Yasser's hit points where he's ran out of registers and he knows he's run out of registers and wants to interleave a little more fine grain instead of doing all the loads up front until you run out of registers. And then all
I've
of
had him tell me. I've had him tell me after a long day. I think he was working on ARM that day. Hey, Shaw, check register 17. We were like debugging something together. This is a long time ago. I'm one X. What do you mean register 17?
exactly.
I distinctly remember him doing ARM for like a day. What's in register 17? There is no register 17. It managed to encode as like something really goofy, and I'm like, oh, that's what that is. You tried to emit a register 17. I see.
So in the land of portable register allocators, the register allocator just has a number for every register. It is convenient if it maps one-to-one to your hardware numbering, but on x86, that's not really possible. At least not on the low numbers. I guess it is on the high numbers now.
Like 6 and up, 6, 7 through 15 are all fine. It's really 4 and 5 that we don't like. 0 through 3 are also rough, but they're just a little weird.
Yeah, you'd get I think it's going to be ACDB, stack pointer, base pointer, and then
SI.
Yeah.
Yeah,
And then
yeah,
you're right.
it's real. But like SI and DI are the only normal two. The stack pointer and base pointer all do weird things. A, D, C, and B all like have instructions that need that register for some reason.
Oh, yeah.
Unless you do IML, which can just take a 3R.
Yeah, right. Some of
X86.
the x86 is not so bad anymore, but there are a lot of still enforced rules. And there are rules like RAX is cheaper in many ops,
Yeah.
cheaper in coding side.
R8 is cheaper in many ops because it's just RAX with a little thing on it.
Yeah, with the Rex prefix, yeah.
Yep, it's just RAX with a Rex prefix. So R8 is also just a little cheaper. R8 through R15 are a little more expensive.
Right.
So like,
Yeah. Like
To be
whole,
fair,
okay.
think about encoding constants in RISC ISAs like ARM.
Yeah.
I do
These
WebAssembly.
These are not uniform encodings.
No, the encoding's a separate problem. The cost is one thing. That's like, oh, go ahead and pick the low registers if you can.
Like
But the
AVX2
encoding
does
is
not
just a different game.
AVX2 does not help you here, okay? Like
Yeah.
at least in risks, you can know that there's a finite number of ways you can encode an instruction. In
Yeah.
x86, they just had to cap it. You have 15 bytes, do what you want with it. Like, woo.
So I've done x86 encodings a couple times, maybe twice before, but it's gotten even bigger since the last one of those. So, well, we'll see when we get there.
Don't forget about Rex 2 that's coming out soon. Ooh, more registers.
You know, by the time you're into so many of these Rexy things, I think adding one more probably won't make a lot of a difference.
It hurts my soul. So like,
yes.
got Rex. I think it's Rex, Vex, Evex, and then Rex 2, I think.
Oh, the Rex 2, good.
But
It does the same.
QEX? Can't they pick up Q? If they're going to do Rex and Vex, how about WX?
Yeah, I
Gotta
feel
be
like
some bad puns here.
I
I think they.
or our names.
Jeez. All right, Hex H.
Oh, there's also Vex 2. Let's see. Wait, Vex.
Oh, there's
There
a
shouldn't
Vex
be.
too?
Oh, they don't need this.
All right, you
And
could
yet,
stop
they
now.
still have the audacity to call it a 64-bit architecture, despite the fact that its registers are 8, 16, 32, 64, 128, and I think now 256.
There are
Huh?
512 registers in the upcoming AVX 10. Like they do allow for
Today I
512
learned.
registers.
Okay,
Yeah.
but those are a different register set than the original set, or they?
They go for, so they sit on, so XMM has YMM sitting on top of it, and then the ZMMs are like also sit on top of that, but there are also more of them. So
Okay.
instead of there being like 16 XMMs and YMMs, there are 16 ZMMs, but there's also just another 16 ZMMs, which
Gotcha.
actually have another YMM and XMM under
Just
them.
like they did with
You
the
can
rest
only-
of the x86, they just doubled and stacked.
Yes,
new name
except they
scheme.
only doubled the second time, so it went from 16 to 16 to 32. So.
Okay,
Yeah.
fine. So these things all show up in the register in their machine architecture description as who gets what registers. It's kind of mind-numbingly boring there.
Yeah.
And I could claim I'm going to emit code.
Don't forget the MMX registers that still have to sit there in case somebody does an MMX instruction for some reason.
No, only if I emit an MMX instruction.
Yeah, but they still have a bunch of if you bought an x86 CPU, you paid for someone to make silicon for these. I'm just saying.
Yes, but I'm not saying that. I'm saying as a portable compiler implementer, only have to deal MMX if I emit MMX.
Yeah.
I will never move -1 to a register. I will always push -1, pop the register because it's shorter, very short.
Sorry, I don't care. That's an encoding issue.
Yeah. In terms
And in the land of dynamic managed runtimes, if you allow for random stack sampling, which is the far superior stack sampling, you do not want to move the stack in case you take an interrupt between the push and the pop. And then that screws up your stack sampling because you can't crawl the stack reliably. Yep. And one of the x86, one of the things that Azul got right was random stack samples. All stack samples are legit. And the stack doesn't move between except right at function calls, in which case the stack sampler knows to check for that case and deal. So you get perfect stack sampling out of Azul, but we don't play the push pop game.
So you don't
We
use
have a
enter
different
and
plan.
leave? You don't leave ever? You don't use enter and leave the best instructions?
No.
What about ret with like an argument? Ret with the argument that like
That's an
pops
encoding
randomly?
issue. So let me treat it as two different instructions. Well, an instruction that moves a byte and an instruction that is intended to do an array copy. It'll be an utterly unrelated instruction.
Interesting.
And the encoding is whatever the encoding is. Like The standard encoding rules are I'm taking generic, simple, ideal ops and mapping them to x86. Array copy is not a generic, simple, ideal op, so it doesn't get mapped that way. If it turns out later in life we want to implement a better array copy, which everyone does in any high performance setup, you have to do something with array copy, fine. You put a node in the graph that says I'm an array copy node, and I take inputs and outputs, and I know how to optimize against other array copies, and I know how to optimize against fills and backwards and forward, blah, 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 all that crap. Okay, fine. Then you come to the encoding side of that guy, and he does what he does. Some of these are going to explode out as here's a small pile of things. Here's something I know about alignment. So I'm going to do more, greater or fewer alignment setup steps to get things on, 2, 4, 8, 16 byte alignment. All that kind of junk happens somewhere else. And the register allocator and the instruction selector actually don't care about it. They won't hit it. So what other stupid things go on here? Encoding, printing, register allocation, code gen. So these will probably be turned into 2 different chapters. In the end, I'll have to register allocate as a separate chapter as a minimum. So there'll be a machine architecture setup, which will probably be an instruction selector, and I might stop that at 19, and then 20 would be graph calling register allocator, and I'll show how to write a fast, simple graph calling allocator that'll do a good job. I've been doing that even recently, again, on a bizarre, yes, you got another bizarre check, more bizarre than anything x86 even. And yeah, you can get good allocations out. It's fine. Okay.
Next.
Yeah, there's the plans whenever they come around. And then I'm doing, work for money and things like that. So it'll show up when it shows up. Although I am still looking for somebody who will code review chapter 18. I guess Zamilia did, but he didn't sign off on it. But he white boxed 1,000 test cases. That was kind of fun. Done.
I'm not signing up for a big code review. I already got enough code review.
You're drowning in code reviews. Yeah, I know. No one wants to do it. That's fine. If it doesn't happen, it doesn't happen. I'll wait a little while and then I'll just declare victory and move on. Tommy will accidentally do a code review at some point because he'll be plowing through it, trying to get his C++ going. And actually, Robert was waiting. We had another guy who's doing the Rust version, was waiting for the next chapter to show. We'll see if he jumps on it too. He actually wants CodeGen, but he's not the only one who wants CodeGen, so I'm going to do CodeGen next.
Is there enough of a test suite to have confidence that all of the implementations of Simple will execute the same code and get the same answers?
I think so. I mean, there is a notion of changing how the fuzzer does things probably coming up. That would be another chapter 18 extension on the million that happened already in 18. Tony certainly, no, people are running the tests and they're getting the same answers. I believe they're running the fuzzer.
There's a slight difference between 3 different people run the fuzzer versus you run a fuzzer that gives the exact same generated input to 3 different implementations and make sure it gets the same output. And it can then explode on you and be like, here's an input that the 3 implementations don't all agree on.
I am not running cross-implementation testing. Maybe there's a reason to do that, or it'd be a way to do that well. I know that the tests get ported, and then they all agree. The tests agree that they got the same answer out. So it's
so at least all the static tests are
all the static tests, yeah. And if you're using the makefile, and I don't know that these guys are, the makefile runs the fuzzer with a different seed at every make. So periodically, from time to time, when I'm just doing some other thing, the fuzzer pops up with a new one, and I go tackle it right on the spot. That's on an asymptotically declining period, though. But if they're running the fuzzer as part of the normal fuzz testing, they should get a steady drumbeat of, we tried this funny seed, we got this funny junky thing, and we got this answer out that didn't look right. So one of the things the fuzzer does right now that I'm probably going to change is it turns peeps on and off and tries to verify you get the same answer out. And the difficulty with that one is in that broken code, where the breakage is discovered, it varies whether you're running peeps or not. And the quality of knowledge you have at the time you discover breakage varies. So the error message varies. And then that was being declared a failure. And I think what I'm probably going to do in the fuzzer is instead say all the peeps run all the time, but the fuzzer will take the same piece of code and run it with a different seed to the work list and then confirm it gets the same answer out, including the error guys who should give you the same precision answer. So I'd get tests that said, oh, you've mixed int and null, and one with or without a peep, and the other one would say you've mixed int and struct s pointers, nullable struct s pointers. Both of them include a null, both of them include an int. One of them also knows that a struct s pointer is involved, and it's an error message. And I don't know, do I care? How much do I care? So, fine. I guess one of the other things that went into chapter 18 is I tracked error messages to locations a lot more precisely. I'm not doing much with it, but it came out as some other piece of work that had to happen. So there is a desire to have somebody to go deal with error message location data if you want. Anyone wants to volunteer? When you have an error, it could say line number X, here's the line number, and here's the pointer where I set it, and then the error message. I was expecting a blah, blah, blah here, but I didn't find one. Fine. No, fine. All right. Something else. Yeah, sir, you're here. You haven't been here in a while. You want to say something?
So, yeah, I've mostly been working on like bug fixing and graph coloring registrar allocators.
Yeah, you're the other registrar allocator guy running around.
Yeah. I've got two registrar allocators, so I'm not cheating on anybody, or it's like a mutual thing.
I'm saying I've been working on a registrar allocator even today, all last week.
Wait, so what's registrar allocator for? I heard something about a funky platform.
I'm writing a registrar allocator for open source, and then I'm directly porting it to this funky platform, which is Derek's not here. Derek's DSP for AI things.
Gotcha.
And it has a RISC-V core in compressed mode, and it has each RISC. I'm not sure what the NDA lets me say. I think I can say stuff. I'm going to say stuff that I think is okay, but knock on some plastic here. The RISC-V drives 64 DSP chips, DSP cores. The actual chip has thousands and thousands of these things. It's like ludicrously big, and the individual DSP cores are really tiny because they're really difficult to do things with.
Gotcha.
They have something on the order of 32 registers, every freaking one of them special purpose. He has a multiply accumulate op directly, and he has a GMV, they call it. It's a basically matrix multiply on bytes only, on small count bytes, matrix multiply.
Yeah.
These guys all take in somewhere between 5 and 8 fixed registers and produce 4 to 6 fixed output registers. The chunks of them talk to each other via sockets. So there's socket reads and writes that also do any count of adjacent registers. You give a base, and then he counts up registers. That's a little unusual in anybody's allocator. He's got bulk memory loads to do the same thing, loads and stores, to small static RAMs. It's not a shared memory address at all, but there's static RAM space for every core.
Gotcha.
And then there's a lot of other things like the 64 cores being driven by the one RISC-V can take registers and rotate them around the core. Some subset, so it's sort of like a 90 degrees. Like we all agree we have a racks instruction on x86, but there's 64 of us. We can all shuffle our racks one up in a big cycle. Or or BX or CX or some other count and move them some other shuffle count. Everybody's conditional. There's condition bits that have always, never, based on this register, based on signed bit, based on this, based on that. There's a bunch of other weird things going on there. Anyhow, as a register allocation target, it is interesting.
Reminds me of a GPU a lot.
Yeah. Yes. This is intended to be, an AI GPU-ish thing.
Yeah.
So that's the port target for, the first port target, and the second port target will be x86. And then time permitting ARM or WASM. WASM sounds like a no-brainer, but maybe that's an easy, here's how you do it for a no-brainer chip port target. And then if you're trying to do something more exciting than that, you can start from there and say, oh, that's what that means. What is a 2-address flag? I probably could change the name now. It's an x86 special. It means that your input and your output register can be any choice of registers, but the input and the output will be the same register. So any add to register, add to racks, does the same thing. Whereas a standard 3-address RISC says I take 2 inputs, I produce an output. 2-address means one of my inputs is one of my outputs. I only have 2 addresses in the instruction encoding. And the allocator has to know about that.
I feel like x86 could have fit a 3rd address in. I'm just saying, they got a lot of space.
I did hotspot with the graph coding allocator on the 8 register version, 83, 86, the last 8 register version. I had that running, I want to say spec JVM 98 in 64 megabytes, getting, record-breaking numbers. And that was the last time I saw an 8 register x86, but the allocator totally worked with it. And then we went to 16 registers, more racks bits, which meant as part of that performance, it did not burn RBP as a frame pointer. It's a general purpose register, and I always used it as a general purpose. Never needed a frame pointer register. So enter and leave, don't use. Just add RSP and you're done.
I like that, like, the reason why we need a frame pointer is because we don't have a place to put, like, how much stack each function uses because we keep pushing and popping all the time. Like, if we stop pushing and popping so much, guess what? We all of a sudden don't need to do all this frame pointer stuff. Wow.
So on Windows, they don't use the frame pointer. Instead, what they have is the unwind info. So effectively, you just describe what your prologue looks like, and then so that way the debuggers can unwind your prologue.
Right.
Yeah.
Same for every hotspot VM everywhere, whether it's x86 or VAX or Itanium or whatever. There's some debug info that describes the stack frame and how you unwind it, how you get an exception stack, and blah blah blah. You can always crawl the stack. I guess at every save point, you can crawl a stack. In the Zool one, you can crawl a stack at every point. But at least for everyone else, you can always crawl it at every save point.
Yeah. For me, what I've basically settled on is that my prologue is really just like hilariously simple. Since I don't have to do since the callee saves and restores aren't part of the prologue and epilogue technically, they're just normal register allocation in the body. The prologue is basically just like, if I have a stack pointer or if I have a frame pointer, I can I save that out, and so I've got like a little, it's like push move subtract or something, and if I don't do that, then it's just a subtract or it's not there. But because of that, like the number of patterns I've got means I don't need like a complicated bytecode if I wanted to do like stack unwinding for that kind of stuff.
Why do you have a frame pointer?
I have the option because people get mad at me about it. I don't use them, but like
a person got mad at you about it. One person got mad at you.
Colin likes them. He's a what's it called? He's in the CCC Discord, but he's a fan of frame pointers, and I know a few other people who like them. The creator of Odin, he also prefers them.
No, you can't please everybody, so you got to please yourself.
Yeah, the thing is, I'm a backend library, so like my job is to please everyone else.
Fine, maybe.
So when are we getting?
Your job is to please a large enough subset of people.
Yeah, true. Yeah, enough people who like, get me money and popularity and all the other fun things.
Right. Just saying, you could ponder dropping that if at some future date it was annoying to do both. Doing both is more than double.
Yeah. The thing is, the frame pointer thing is like mostly not a problem. So what ends up what it changes is mostly the register allocator has these two masks that are for like I call them like the normie masks and then the mace bill masks. So the mace bill is like told to the register allocator for that one's if the register allocator wants to say this register class I want to spill it, or like I want to broaden its like its mask, how many bits can I get away with? And so like the normie mask is like, oh, it's just every bit but like the stack pointer, or if you have the frame pointer on this, every bit but the frame pointer as well. And it just says like, okay, if I can broaden some if I can broaden some mask, this is as far as I can go for this register class. And then mace spill is just like the same thing, except also it can spill. Yeah.
So I always did. Well, I guess it's not fair. I went back and forth. You're right. On the spill thing, I always had a. I keep saying that. Let me try again. On the spill thing, I have gone the route of I just widened the default mask to include a fixed count of spills that was always so large that no one ever ran it out, and I carried the fixed count around. That worked well when you weren't going to have more than hundreds of things live simultaneously, which covered a lot of ground, especially in the early years of compilers and hotspot also, whatever. And then
Why
there
is
was
it
a
that the
version.
size of live ranges has been growing over time?
Yeah, it's the simultaneous count, which if they get longer, then they get a larger count too. It's the simultaneously alive count that matters here. And then the other version of that one is you have some sort of overflow bit that says, I also include spills. And then if you've gone into the spill place, then you have extra data, which is an arbitrary large amount of more spills.
Yeah.
So like in the land of, I'm going to say spec FPPPPPP, the spec not Java ones, spec class things from that era. That was a machine-generated, machine-unrolled Fortran code, which peaked out at about 350 things simultaneously live, which tended to blow up everyone's register allocator. And I was able to make a combined giant basic block linear scan register allocator scheduler for the giant basic block that cut in half the amount of spills that we were getting over like what IBM was getting. You had a poor schedule and half the spills, and that made you twice as fast. All them loads and stores went away. And then the amount of simultaneously live things dropped down into 100 or something, and that meant that I probably could have lived with a 128-bit mask. That was somebody else's allocator, so I wasn't doing it there. But outside of that, like C2 certainly started life with a 64-bit mask, and I think it moved to a 128-bit mask, and a separate pile of bits for the FP, maybe. But it didn't ever get a larger, like it knew what you were spilling or not, but I don't think it ever picked up an indefinitely sized pile of spills. That was not a necessary thing as a mask.
Mine technically, so I've got like mine is split up as like register classes. So I don't actually put all the registers into the same mask.
Right.
Class, mask, and the number of bits for the mask is like it's like 64-bit chunks, but it can grow indefinitely for two reasons. One of them is because the spills can technically you can have an infinite number of spills, and so there's like that number. There's because of that feature, I was like, okay, I don't have any restriction that makes it so that I have to limit it to like 64 registers for like physical registers. So I don't limit it there either. So if you wanted to ask for like 256 registers, you could have it register allocate for that. It would be I mean it would work, but I don't know what the implications are on like any of the heuristics I've got. And then the other piece is like what's it called? Oh, yeah, I do end up using past 64 bits on some real cases. One of them is that the way that I do the stack is that there's a register class for the stack, and then that one has, I think it's the bottom register is the return address. Then it's like the parameter stack slots. Then it's I think the callee like parameter passing sites, and then after that is like all the spills. And so because of that, if you have enough parameters being passed or enough parameters coming in, those can blow out the like 64 bits.
Right. Some giant call takes 200 arguments.
Yeah, exactly.
Pass on stack. Yeah, right. Yeah, that's a good point.
Yeah, which was annoying because I ran into that like the other day. I was like, oh, I was like testing stuff, and I was like, wait a second, what happens if I put too many things into this thing? And it's like, yeah, it just blows up.
It just blows up. It's always useful to at least have a test somewhere that you get the polite blow up instead of the generated broken code crash at runtime blow up.
Yeah. I want to write a fuzzer like you guys have, but I've just been too lazy. I used to have a C fuzzer, but it was bad. It was like slow and unruly, and also didn't really tell me whether or not things were like valid or not. It just let me validate against other C compilers to see if they got the same answer. But if
I see.
compilers didn't agree, then like I would also like end up in like a limbo of like, if they don't agree, is it because the thing didn't prove that the thing had no UB, for instance. It would just say like, okay, if the thing is valid, then they all should agree. If it's invalid, then they may or may not agree.
Gotcha. So in the fuzzer we have, he produces something and he has a flag that he flips back and forth that says, I know it's valid or I know it's not.
Mm-hmm.
So if I get a it should be valid, he then goes and says, validate with and without peeps running. Mm-hmm. And that means you get all the way to the end, and then you get a report of the exit value, which is frequently 0 because he's always writing stupid code. Mm-hmm. And then he runs it a fixed count in the evaluator and agrees at the end of the fixed count that it didn't crash, so nothing else to be done. If it terminates, he requires everyone to agree on the same termination value. Gotcha. And he tries a couple different argument inputs, but he's really dumb, so like I said, it's usually just goes to 0. Then if it's going to be an error, he wants the error messages to come out identical to everybody. But this is not two different C compilers for which people might agree that they're going to disagree on what an error message means. Yeah. C-Smith. Oh, I've heard of C-Smith.
It's from the John Reger's group. What's important is that it outputs programs free of undefined behavior. It actually used to find a lot of bugs in GCC and LLVM or plant, so this may be worth a try.
There you go. You put output.
I did see it one time like 2 years ago, but I have not seriously tried it.
Might be worth it. Yeah. We got a lot of mileage out of the fuzzer.
Fuzzing's especially great. There's a bunch of dumb cases that like I'll never do, but like are like just degenerate versions of like things that I that probably will come up.
Right, and right, exactly. People will do the stupid thing, and now at least you know you're not going to fall over it.
Yeah.
Because there's things you thought. You know, when Chrome first started using debuggers on their JavaScript VM, they turned it on and it immediately discovered that 16K of OpenBrace crashed the browser.
Oh, there you go. How about a denial of service attack there?
It's just like create a namespace, create a namespace, create a namespace, create a namespace, Stack Overflow, done.
Let's say 16K after you encode it with a little bit of HTML header and a little HTTP, blah, 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 blah. That's not very big at all. You touch some website and, from a whatever.
2 kilobytes with gzip compression. Final answer.
Yes.
Also, I'm very skeptical when anything claims to be free of undefined behavior. It's like,
Matt,
okay, so what are you supposed to do when the chip melts?
Matt added some links.
Yeah, but you should be able to get rid of. Now, I know the chip doesn't. That's hardware undefined behavior. That's different. The C language undefined behavior is well described mathematically. That one you should be able to do.
Yeah, there's some undefined behavior that's like at some level we're like dealing with like we have our like baseline like axioms like we expect the universe to keep running and stuff. Right. And like I think it's safe to assume that kind of stuff.
Yes.
The C spec standard writers are just lying. Okay, that's how we get undefined behavior. They're just not telling you the truth here. No, I like when I think it was like C Smith was like dealing with, I think it was some sort of verified C compiler that like verified that the output was for the program that it gave or something. Don't
Oh,
remember exactly how.
yeah.
And the two of them together somehow figured out that like using C Smith on this compiler ends up proving that the C standard can't actually be implemented. And they like released a patch to the C standard a while ago that was like, actually it can, because strike that out. There was
Right.
just a contradiction in some of the logic in the C standard. It was like, you
Yes.
can't technically have written C to the standard
Right.
because
Right.
it's inconsistent in some way that like
Right.
makes it impossible to do.
The bigger one I see is like there's a few like dumb cases where the C standard will like ban something that was like probably shouldn't. So one of them, I think it came up with pointer difference. It was like they specified pointer difference, or like the basically, the maximum distance you can cover, or like the min spec on like pointer diff was like slightly off, like it was like off by one, where you couldn't specify a 16-bit machine without it like violating the rules of pointer diff or something like that, because it would need a 17-bit like pointer.
Yes, pointer diff T would be
Pointer
17.
difference that would work.
Right.
Because you can't, because with a with a 16-bit number, you can't do a range that like goes from one end of like, or well, you can by cheesing it, but like you can't get a like without overflowing a signed integer. You wouldn't be able to get a difference that goes from one end to the other end.
Right.
It was something cheesy like that.
Same problem repeats at 32 and 64 bits, right?
Yeah, but like they min-spec the pointer diff to like.
The min spectrum. Oh, yeah, okay, never mind. Right.
Because they were like, it's going to be like 16-bit. It's like, well, if it's 16-bit, then you need a 17-bit like pointer.
Right. Okay, fine.
Yeah.
We've had all kinds of cheats like that in history. That's like, oh, I added a 16-bit number to a 16-bit number. I get a 16-bit number, and go check the overflow bit if you care about. That's just a secret extra 1-bit register for just such an occasion.
Right.
I want a register of every bit size, just one of every size.
The C2 definitely has a pattern match for the obvious way you check overflow bits, because big integer math would add two longs and want to figure out if they overflowed. And he has this canonical pattern he does. So C2 matches it and says, it shows up in the carry bit. Okay. Or the overflow bit. And he actually shows up in the overflow bit. He matches on that one. Fine.
I had one math professor who used to say that when you're multiplying two 32-bit numbers, you get a 32-bit number just with a 32-bit overflow bit.
Yeah. Yeah.
And I was like, that's kind of sure.
Yeah. Not 32-bit, but yes, you have 32 bits of overflow. Yes. It's all good. Know your ranges.
Splitting and
This was the same teacher who tried to explain floating point to us by pulling out a slide rule and being like, it's just like your slide rules. I was like, you have not updated your slides recently enough.
I have a slide rule from my father. Oh, it's upstairs.
Like, slide rules are so easy to understand. I don't see a problem with this.
There you go.
To teach someone a slide rule in order to teach them how floating point works.
How logs work.
Yeah, it's a great teacher of how logarithm, like any of that works. That's
Right.
actually great.
I had to use them in high school.
You have 12 inches, and you need to measure numbers from like 0.1 to like a million or something like that.
Right.
How are you gonna fit them all? I wonder what the solution is. They just like quantize the logarithm, and boom, we're done.
Right. And of course, I have my dad's high quality engineering slide rule for doing high quality engineering work. So it's this long and has magnifying glasses and is sort of high precision and everything else.
Oh yeah, those 3-digit slide rules are
No.
that's
This
precision
one's 5.
engineering.
You use the magnifying glass, you can get 5.
Oh damn.
Yeah. It's high quality. This is the kind of shit you build dams with.
Now, I've seen like a 4-digit slide rule, and I was impressed. 5.
We talked about it in high school, how you read the things, and you can pick 5 out on a big slide rule.
I didn't have it. Like 4 was about as far as I could be consistent at, because I just never learned it from people who actually knew. I was just like, I'm gonna guess how to use this thing. Okay, good enough.
Like I said, I had to take not a class, but we got introduced to it. When did we get introduced to it? Damn it. I know that my first chemistry teacher had us using it, and somebody else, and then TI calculators were all the rage, and there's a lot of back and forth about whether you could or could not. I certainly had tests where I could use a slide rule and not a calculator. So there you go. Different world.
I mean, you could always use the Taylor expansion if you felt like it.
Not by hand in an hour-long class. And it was high school.
No, I definitely had that. I had one test in college where the entire test was essentially what is the natural log of 2 to 14 decimal places? No calculator, go.
I don't know the natural log of 2.
Yeah, sure.
Yeah, I think something like that was.
You just memorized it and used the test.
You knew it was coming.
Well, they were gonna pick natural log as some number, so I just memorized a bunch of them up to a 10. Like,
I wouldn't have up to 10. I think I've got maybe 7 digits of pi because it's enough to get around.
Now, quick, natural log of e to 1,000 digits.
And then I'm out.
Yeah, it's
here's what I would. Here's the issue:
3.14159.265, and that's where I cut off.
Oh, you're ahead of me. There you go.
I just keep saying nines until they figure I'm at the Feynman point.
But how many digits of natural log of 2 can you do?
Natural log of 2.
Let me pull out my calculator.
Nope. I can't do it.
Sure, I have this calculator too.
Ooh.
But this one I bought later in life because I wanted it as an antique. I didn't actually use it. I didn't use it.
The fun one about natural log is you don't have to do the Taylor series crap. You can just guesstimate, and we're pretty good at that as human beings.
All right, I'm
better than the Taylors. Anyway.
Drag it away from high school calculators and Taylor series. I don't know what we're going to drag it to.
Yeah.
The question I was thinking about for this week is there's a lot of situations where you want to have some kind of code validator that looks at the code and decides that it's sane before it tries to run it. The JVM does some kinds of validations on the bytecodes before jitting it.
Every compiler everywhere.
Once you have that cost at link time, does it make sense to say, oh, we're also going to rewrite some of the function interfaces there and kind of make the ABI compatibility go away? Because if I'm trying to call a function and the recompiled version has that function with arguments in different orders or whatever,
if you
is it that much more expensive to have a dynamic linker that's kind of jitting a little trampoline between the two pieces than to do the validation?
If you're in your ivory tower stuff, you can do whatever you want. It probably makes sense to you.
You touch disk to go get the data, to go get the link files in the first place. You've got eons and eons of time to write these little trampolines.
You're saying the validators just totally disappear into the
absolutely.
read.
You could write those rewriting signatures straight into your L1 caches faster than you could get the signatures from memory to your L1 cache.
And yet I've still had cases where I tried to load a DLL and my system balked at me and goes, this DLL needs to be recompiled because function signatures don't match anymore.
Right. Not nonsense because somebody didn't bother. Like hotspot. All things call all things via every interpreter or every function call versus C code. So there's 3 ways. There's native C, there's JITted C2 code, and there's interpreter. They all have different signatures. There is a signature generator in hotspot that just maps between the signatures. These are all cached. So if you come in with 2 signatures, he looks in his cache, he misses, he jits another one, and then hands you a remapper. That thing, if he misses in cache and remaps, probably takes a few microseconds to go spit out the wad of 10 to 20 instructions necessary to go do things. And if it hits in the cache, of course, it's whatever nanoseconds takes to hit in the cache and hand you some code. And then you just map between 3 different calling conventions. So, well, I could have 5 and 17 calling conventions and do the same remapping job. It takes no time. So
you think a DLL loader should just handle all those things?
Yeah. You have to have precise knowledge of what the calling convention is. Like you can't take a .o where somebody doesn't include in the .o, we're using ABI 64, we're using GCC x8632, blah, 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 whatever the convention's going to be, the Windows versus the Linux, or I don't care what. If you have that knowledge, though, the cross-compatibility spit a remapping signature out, nothing. The code, I could probably drag the code up that does it if I can go find it in hotspot, and you'll see it's
Not bad.
as stupid as you get. You know, the worst case scenario is I put a little space on the stack, I take every registers and I puke them into the stack, and then I load them back out of the stack into registers, and I throw my little stack space away, and then I jump off.
I mean, that was my instinct, is it would mostly be register shuffling
yeah.
before the call and after the return.
Right. It's a little register shuffle.
I've got like a thing like that for jumping into JITted code for my backend, and it's like basically some sequence of instructions that reads off this struct, like, oh, first parameter, second parameter, third parameter, fourth parameter, or something, and then the rest are like on the stack, and it just like positions everything correctly. But like you could just keep using one of those things if what you need is like, hey, we want to be able to like change the API and do dynamic linking or something. Yeah. The issue is that there's like a bunch of the issue around API changing is actually like a bunch of politics of like people who want to and don't want to do it. It's like that came up, I think, with what was it? Also, there's like the classic case of like, oh, maybe we want to like change like parameter passing for certain kinds of uses, like C++. I think this was like the premise behind Carbon, wasn't it? Like there was, or at least this was part of it, which was like, oh, there were people who worked on Clang who wanted to change the API and who didn't because certain things like passed around in C++ were like nasty. There was something around that.
So what you can't do is change like lifetime agreements.
Yeah.
If somebody says, I'm handing you a pointer and your job is to delete it when you're done with it, and you don't leak, but you don't know that's not typically recorded as part of the signature. There's another one that
so
says,
I would argue that's API change.
Yeah.
That's something the programmer cares about. That's not really API.
Yeah, no, but for their case, I believe it was something about like how certain C++ objects get passed around.
Yeah, copy
like,
in, copy out.
Yeah, exactly. Do we want to do it? Do we want to keep it the old way or not? And it's like, well, we can't change it because changing it would require like either some funky trampolines or whatever else, and like it would just be they're like not just trampolines. C++. I don't know how to explain it. There's like the ivory tower sort of design, and there's like this like really like open design that C++ and C have, where like everything is exposed really like deeply.
Yeah. So that's a standard answer in the C++ community is we cannot do blank because we'd have to recompile the world.
Exactly, yeah. It's like a lot of this would be fixed if it wasn't set up as, hey, we need to like treat a bunch of little object files and everyone keeps a bunch of these that need to be recompiled all the time. It's like a lot of this would be solved if there was like either and some of this is already being dealt with by the fact, like by the beauty of like LTO, but it's not like a standard. It's just like an option that lets you not say, hey, I'm passing around machine code everywhere. Because machine code sucks.
You can get that doc in here, Stack Overflow. Okay. Yeah.
Right. And people are like, we don't necessarily want the linker to become a JIT, but
But also, I kind of do.
Why? Like, let the linker become a JIT and do dynamic load time things.
Yeah. Also, so the way I frame it is usually that I just don't want a linker. I just want I want my compiler to spit out executables, and then that's it. But like all the LTO has done is just done that, except we have two compilers now, because both of them are capable of producing machine code. But they're both separate applications usually. So you end up with like a 90 megabyte like Clang and a 90 megabyte LLD, and it's like, what are these things? It's like, well, there are two LLVMs in there, like the whole thing.
I mean, so that's when I snap back to my maybe we should just distribute source
I think this
as
is
the
what,
language.
I think this is what Yasser is talking about. This example of unique pointer having overhead compared to the raw pointer. Yeah. If you click on the...
So it can't be passed around and registered because for non-trivial types, they don't know whether or not you care about the address being stable or something stupid. Like, I don't remember.
Yeah, because constructor and destructor, and I think constructor and destructor need to have the instance pointer represented as the this keyword, which implies having an address.
Yeah.
There is a link to the Godbolt too.
I'm like
compilation results, underscored compilation results in the beginning of this. Yeah, that's it.
Yeah, but essentially there was like politics around this stuff, and from it came a bunch of like random things. I think what was the other one called? I think it might have been Herb Sutter.
Oh, CPP front, so CPP front 2, something like that, yeah.
Yeah, I think he also had like a separate language that was also born out of this like politics. I can't remember though.
So which one's getting passed only in like the bottom one? He's passing the address into the thing.
Yeah, like it's passing around the address of the pointer. Even though
Yeah.
it's a pointer size thing and it could pass it around as a register, it just doesn't know that like it's not allowed to because of ABI and also because like rules around like, oh, we do this because blah blah blah.
So this is like goes back to the old as if, like how are you gonna tell?
It's like one more layer of indirection. If you compare the top with bottom, you will see that on top with the row pointer, he just has the address.
Yes.
Whereas in the bottom, you see he's gonna have to load the address from RDI. He's gonna load the pointer from RDI, and then he's gonna, in line 5 of the assembly on the bottom, he's doing another load from the address in RDI to RDI, and only then he can compare.
Yes.
Yeah. No, in the as if rule sense, like how are you going to tell? I have actually no clue. The same thing comes up. There's a few other cases like that where, for instance, like const doesn't mean anything as like a parameter, but like const probably could mean something. Like if I passed around like a const, or this, well, the issue really is that const is like semantically meaningless in C, or like it means like read-only reference, which means that like somebody else could be a writer reference, and like you can't know. So like there's no mutability guarantees.
Yes. Same with final in Java.
Yeah.
Up until reflection, final is final. After reflection, final means nothing.
Yeah.
There has been some talk about removing const cast. That would be actually interesting to have const with a semantic meaning.
I used const to give me hints that, but you often use const over a caching layer, and the caching layer obviously modified things underneath the hood.
Yeah.
And above this layer, you were expected to act as if it was a const thing, and below that layer, well, yeah, we looked up and we cached, and every union find algorithm everywhere does that kind of modification. So yes, counts wasn't const, but it was still semantically a hint.
And technically, there is a little bit to meaning of into casting C++ because you cannot cast away the constness if the object was initially const. So that's undefined behavior. So you are allowed to optimize assuming the constness holds here, but you would have to track this.
Well, yeah. So the issue you run into is that what const tells you is basically just that your reference is read-only and that no references can be derived from it that are read-only. But if the const is derived from somebody else and he's mutable and you get a const from him, nothing is saying that somebody else couldn't modify it at the same time. It's like, and that can happen interleaved with your function. A function can be passed 2 pointers. One of them is a const and one of them is non-const, and they're both the same pointer.
Right. You would have to do really advanced tracking, like interprocedural flow, which would be pretty expensive for a compiler.
At that point, and there's also like the thing that like LLVM doesn't like take in. I don't believe it does even to this day. Like take in const as anything meaningful because it can't make it. All the guarantees it can make out of const are basically just I promised personally not to write to the pointer, but like if you needed to know that, you could just ask, like you could check the graph because it's all local.
I think I recall one example when it did make an example of a difference in a static that was a global, because then it implies it could be put into the read-only memory. Yeah. So things like embedded, you can make something ROMable, so it can go into ROM. But
the exception is there because when you define something as stat or as const in like a global scope or something like that, what you're now saying is that like the root object is const, so you can't take a mutable reference now. There would be nobody above him to take it from.
Yeah, right.
Yeah.
Right.
Assume you have a global, found the top of the global space. Yes.
Yeah, and so now like that's like the one case where it technically matters, but in like parameter passing or anything like that, it kind of just gets erased.
Yeah, that makes sense.
Yeah, immutability would be fun because the nice thing about immutability is also aliasing. Immutable things don't alias immutable things.
Oh wait, const. Well, const can though because you obviously
const can.
Fine.
Yeah, I would love.
I had just started programming. I definitely tripped over the whole. This is an immutable reference to a mutable collection thing.
Yeah.
Yes. And for the longest time, Java would have I could have a final pointer to an array, but the array contents are never final. They can always be modified.
But that's the fault of reference semantics. That's why I claim reference semantics are bad. Because they are not intuitive.
Not intuitive, but this is how the world works. We couldn't write 99% of what we do without some kind of reference semantics somewhere. So I think people have to learn that one. That's just part of the game.
Although if you start passing around weird L values that are like a reference to the fourth field of a struct.
See, that I don't like using the reference operator in C++ because it does hide whether I'm talking about a pointer to, and it's explicitly a pointer to, or I'm talking about a thing I've copied into a register and it's now value semantics. I know people used it a lot both ways. Last time I did C++, been a while, never touched reference semantics games. I always just said, fuck it, it's a pointer now.
In AA, if I try to pass the field of a struct into a function,
yeah,
I assume it gets 2 pointers. That's like, this is the pointer to the base object, and here's the offset. It's not just...
No, if you're a C++, you get a pointer to the field as an address. If you wanted to have garbage collection and do something meaningful with whatever, keeping your semantics run, then yes, you would need a base and an offset. But as far as I know, certainly no C++ compiler I ever used would pass around base and offset. They just...
Yeah, C++ just pass around pointers to the middle of objects.
Yeah.
My question was for AA, are you going to disallow passing around pointers to the middle of objects and say you only get a pointer to the base of the object and an offset?
Right. In any language that has garbage collection, you want to do base plus offset. And you can just hide it under the hood, and it takes in fatter registered values to pass around, but base plus offset. Not that I would intend to say I want to pass around the middle of a pointer directly, but I thought about doing how to do those semantics at various times. So yeah, probably I would now that you've said that. And it shows up in other
places. There's definitely times where I want to call a function and be like ampersand struct.field.
Yeah, right.
Because I have this thing that takes a mutable integer and mutates it in some way, and the thing I want to point it at is the middle of my struct.
Right. I was coming up with examples where the array lookup operators wanted to be, in order to be generic, wanted to definitely provide address of, which would be base plus offset. And the generic guy was like, I actually work with like dictionaries and hash tables and arrays and every other thing, structs, I don't care what. You do a lookup, however you look up, I'll give you base and offset under the hood.
Right. If you give me an L value to an integer, I don't care if that's in a struct or an array or a hash table. It's an L value to an integer.
Right. And then you can do plus on it, things like that. Fine. Yes. So that would be base plus offset was already in the plans for AA. Yep.
And I would argue that if in the header of the function definition I say ampersand integer, that should take any L value to an integer.
Well, this gets into how do I want to represent such a thing, and I don't know, like I don't know what the right typing answer is. If you define an L value as base and offset, and everyone knows that ampersand means base plus offset, and I got that from an L value generator, which is ampersand of something else, or dictionary lookup, array lookup, all things that produce L values. Maybe that's the right semantic type.
Yeah, I just don't see any reason in a modern language to expose a raw pointer. I think if you put an ampersand before a variable name, what you should get is the L value of that variable.
If it's not moving, I don't think there's any difference. Like this is an as-if implementation detail. You don't get to see the base and the offset. So as a user, you have no clue whether you're looking at base and offset or a raw pointer on purpose. So the implementation can do what it wants. In a non-moving system, there's no reason not to just change the one pointer. That's fine.
Right. The distinction there is if I take that thing and then I add 7 to it.
No. Disallowed. Period. End of statement.
That's like you can't add an integer to an L value. You can add an integer to a pointer.
If you're talking about a memory slice, then you have a different structure involved. And the different structure has, base and offset and range. And now I can tell you whether or not it's sensible to add 7 or not. One of them does not allow adding 7, one of them does. So there's a difference. So I'm doing Java values, values semantics, the Java value classes or whatever, the inline classes, the inline values, blah, blah, blah. Is it sensible to add numbers? Well, it's the same as array lookup with adding numbers. If I know the size or the element count or whatever, there's a bunch of rules on when it makes sense to add 7. But I claim you're now into like array slice land. And
then an array slice is just a different value than a L value of an element of an array.
No, a slice could be exactly an L value of an element of anything, with the rule that you can't add one. I got a struct that's got an age field. There's no something after it. The struct fields get scrambled by the layout generator when he builds the class. You don't know what the next field is. Adding 7 makes no sense. But I can still make a slice to it. The slice will just say 7's out of bounds. Done. You threw an out of bounds error. If you add 7 to the slice, right? So an L value in that sense is a subtype or a subclass of a generalized slice. Whereas an array can be considered a slice with a base pointer, and the base range is 0 to the array length. It's just another slice.
I mean, I do think most functions should take slices, not arrays, and just be like, I care what the API is to this thing. I don't actually care what the backing storage is.
Right. So in the land of Java, no slices. If I want to play that game, I have to pass in an array and use some discipline on what it means to be a slice. Have I had a slice thing handed to me, I'd be interested. But again, I'd have to proclaim the cost to be low, because I know the cost to pass in an array base and have knowledge about what it means to be in an array is pretty cheap.
So like in JavaScript land, people make a lot of fun of the automatic casting that happens.
Yeah.
But if I have a function that takes a slice and I try to pass in an array to it,
that's not my question.
I kind of want that to just become a slice, because arrays implement the slice API. I don't really want something that says compiler error, you needed to type .toSlice.
I would have said a slice is an array, period, end of statement. They are just the same thing. And then the only question is whether or not the base pointer is well, I guess that's not fair. You're right. No, you're right. You need a separate allocation.
Because slice is an interface and array is a data structure.
And an array costs you memory. A slice costs you memory if you allocate it. And this is the thing I'm trying to dodge.
Yeah, the annoying thing about like having a slice in a managed language is like I want to be able to access the object header, and like so I don't want to store the base and offset separately, but like I'm trying to think in my head, could I pull it off without doing so, without making a data structure that would be annoying to deal with? And it's like, maybe, I don't know.
The thing that a slice is like 2 or 3 bits. It's an array base, an offset, a starting point, and a length, something like that. If I allocate the slice so it's its own first-class citizen, I did an object allocation in order to make a savings of doing something with an array. Sure. If I have semantics where it's exposed to me that I've allocated this object, you'll drown object allocations because you can't get rid of them, and you have issues. If a slice is a value citizen only, then it's thrown in some registers. It takes me 3 registers, not an array, not an allocation. If I allocated, I cache missed, I burned a huge buttload of time. If I burn 3 registers, I don't fucking care. So I want a way to say I have a slice, but it's a value object, like an int or a float. And then the implementation of the hood does what it does. It makes a struct on the stack or not. It passes in 3 registers or not. It shares this or that register or not. I don't care what the implementation does. Don't allocate when I make a slice. And then I'd be willing to use slices all over the map.
But you could imagine a place where you would want to allocate because you made a slice and say,
I have a first-class slice.
This is my map from index to slice. and I've got one backing array, but I've got 10,000 slices in this map.
No, that's an implementation detail. How do I store a slice in an array? And
Yeah.
and I'm not going to tell you how I did it. And maybe I copied 3 values in, and it's a headerless object, just like Java's value objects are trying to be. It's just 3 bits in memory, and maybe it's something else. But you don't get to say instance of.
And the compiler gets to choose if it wants to be overly clever.
Yeah, right. So the difference here is that it's not a first-class citizen. You can't say instance of. If I have a primitive int, I cannot ask it an instance of question. Cannot even ask it. The fact that it's a primitive int is already its only class, and we're done. There is no instance of meaningfully, but I can't even ask it. Because to do that, I have to go to the object header, and primitive ints have no object header. Fine. Same for slice, has no object header. You can't ask instance of. You're a slice, you're a slice. Just like you're a
Well,
float.
doesn't instance of just become essentially a compile time macro at that point?
No, it becomes, well, it's essentially.
Because the
no,
compiler knows
no,
it's an
no.
int at that point in the code. So if you call instance of on it.
So in the land of Java, the reason it makes no sense is because there's no class for primitive int. Capital I integer is not the class of primitive int. Capital I integer is some wrapper class that happens to play fun API games, and there's some syntactic sugar thrown around it, but it's not the class of a primitive int. So you can't ask instance of primitive ints. That make sense? So there can be a wrapper class that wraps a primitive slice and gives you a thing you can ask an instance of question that allocates memory, that has what other properties in Java. You could lock it, you can hash code it, and system hash code it, and whatever. But I can't in Java say int, 17 dot hash code and give me the hash code for primitive 17. There's no calling a function on 17.
Do you have anything in simple yet to be like, what does it mean to say ampersand variable name?
No, and that's no intent for that either. You're going to say, I have a struct, and if I want to struct in field, I'm going to have to manage the field offset myself as a thing that says I'm referring to this field.
But if I put an ampersand before the struct, do I get the pointer of the struct?
You only get, no, it's just like Java. You get your references from the get-go. So if you say I have a struct, you actually have a reference. You got the address. Same as Java. Just as you would expect to see a struct back there. I mean, a pointer right there. What is a good share here? But I don't know that this is all obvious what it's doing, so I have to go change this guy. Go find, let's see here. And then view, parents, yeah, zoom, whatever, 150% maybe. Wow, that didn't stick. How about now? Try again, third time around. Why did you wind and unwind? Okay. What do we got here? Somebody got some structs for me. All these are right here. Here's a struct on the left here. Struct s, new s, blah, blah, blah. So here's a declaration. Definition of struct. Here's an s, little s. That's already a pointer. Does that answer your question?
Yeah, I think so.
Okay, so that's every time, everywhere.
And then I can just pass that around.
And you just pass that
Well,
around.
I can't pass it into a function because there are no functions. It's simple.
No, there are in chapter 18. That was the whole first half of the conversation. There are functions in simple, and you can pass structs in. Here's a struct. Here's a function f. Takes an int, which is some counter, and it takes an s. Runs the counter down. If it goes to 0, return s. Otherwise, recursively call f with a lowered counter. And then I get a struct back. And if the struct is null, do a next. Otherwise, return a null, and then go ask questions about it. It's like, this is a stupid fuzzer thing. It's nasty, but you can pass a struct around. I mean, this code is essentially syntactic sugar away from a Java or a standard sort of C, C++ thing. I could write this code in C, Java, look almost identical. The parens
And by
would move
default, that's
around.
mutable. If I mutate my parameter, I have mutated the thing in the caller.
No, this is passed by value of a pointer. If you mutate s, so you come in here and you say s equals 1, 2, 3. Well, it's a pointer. You can't say 1, 2, 3. But if s equals something, you've changed in your copy, not in the callers, because you changed the local pointer s.
Okay.
Same semantics as you get out of standard pass by value on a pointer. You could say null here, fine. No change. Is there another good example here? A lot of these are test cases and exploiting on things, factorial. This was an uglier one, but it worked. Here I'm taking a parameter x. I'm returning a new struct where I initialized I to x. So I call my new function with some parameter and it loads it in. So you can return functions by pointer. You can pass them by pointer. Very, very much like the very trivial versions of Java or C or anything like that. The goal here is not to have any surprises. It's to work as expected. Yeah, here was an uglier one, but this was about half of it was null pointer, half of it was something else. I forget what he was checking on here. I to I is a function that takes an int to an int. It's nullable, so I may not have such a function. Id takes a function from int to int and returns it. It's an identity function, but pinned to being a single type because I don't have polymorphism. If I have a function called on arg, otherwise make some kind of a function called on 3, set arg, I can set arg, call that on the id function. So this is a function, I can pass it into this. I get back an int to an int function, which I can pass around. So this is just first class function citizens. Yeah. Nothing really exciting here going on. A lot of fun test cases. Here's break in the middle of a function. That was a break in the middle of a loop. So that was a bug for a little bit. Here was a properly done null pointer check was being missed. On the first go around, I to I is not null, so you can execute it and do something. On the second go around, it is null, so you have to throw an error and say, no, it might be null when you make this function call right there.
All functions are like classes. They have reference semantics. They're like pointers.
Functions are function pointers like you get out of C.
Mm-hmm.
Java, you get method handles. It's a little different because you have to handle this pointer. So I'm not sure we have my reference semantics. Yeah. It's a pointer. Okay. It's a code pointer. The implementation expected here is I'm going to make an x86 call op where this address, the address that got mapped here, is the static call address you're getting called, just like you'd expect out of a C compiler. I'm not sure we do my reference semantics. There's no reference, there's no memory pointer.
Yes, okay.
But it can be null.
But you can assign it null. That was
you can assign it null. Yeah.
And if I try to call a null function, that's a compile time error?
Yeah. Might be null calling. This is the test case that we want to make sure we believe in. So the compiler does null pointer analysis as part of the type safety. And no one's allowed to call a null or dereference a null pointer at any time. So you can't have null pointers in simple. Null pointer exceptions in simple. Sorry, you can have null pointers, you can't have null pointer exceptions in simple. It's a compile time error.
That does seem more convenient than the runtime error.
Oh my God. How many times in JavaScript did I get null is not a function and no stack trace? And where did my null come from?
I get undefined is not a function much more often.
Undefined. Yeah, undefined is not a function. You're correct. Undefined is not a function. Jesus Christ, what a bitch to go debug that. And of course, it's the stack of the doom stack of callbacks. Somebody blew it and didn't set a function somewhere, and you die. It's
The
just
beauty
such
is when you spend 8 hours debugging it and it turns out that you misspelled something.
yes,
So it just gave you null because fields
yes.
that don't exist or
New
do
variable.
exist, they're just null.
Yeah, it's just a new variable, right? Yeah, here was one. This is struct s has a final constant field, which is just a function that returns an int. So here's a function that returns an int. Here is the function, that's the type, that returns an int. And it defines a forward reference to an unknown x function, which I was picking up as accidentally as a field in struct s instead of as a forward reference. And here is the forward reference being defined. So, hey, great.
So if you can assign the function or no, but if it's if the compiler cannot decide it because there is an if statements which cannot be tracked at compile time, and assign a no or something else based on that, how can you determine that can be no or not? Because
right.
the
How do I know? So this says might be null. The test expects to get an error, might be a null. Okay. How do I know that this is nullable or not? Standard flow analysis.
Mm-hmm.
I got a not null value here. I put this in. It's not null. And I'm tracking this. I get a feed function here, and I'm tracking this. And when I parse this loop, I see it's set to null. It merges around the back edge. The fee merges a null and a not null. So it's a nullable function pointer of int to int. So
but if you cannot discover, the branch, you cannot discover the value. You cannot discover the branch go either or that way. You have to emit.
No. This is a flow analysis on the program. I can't. There is a back edge, or you have a syntax error. You started a for loop. You have an infinite while loop here. Whatever. You have a back edge. There is a value coming around the back edge, or the parser stopped before the back edge because of syntax error. The parser only stopped because you have syntax error. No syntax error, you made it to the back edge. The back edge brings the value around. What is the value that comes around? The compiler now has to go prove it. So you get a graph here. Geez, wait, here we go. We can. This is probably not a terrible graph to stare at. And the whole graph viewer thing. Wouldn't that be funny? Simple. Chapter 18. Make view. Boom. Okay, now let me hit the share the other way. Stop share. I want to none of these. Go share this guy. Share. Okay. Give me back to this. Thank you. Boom. Boom. I just cut and paste the program into the viewer.
Yep.
And then I'm going to run to the end because it'll get ugly in the middle. And I don't have the jump to end because I quit doing viewer things to get functions done. And if somebody wants to hack on my JavaScript to get my viewer to be done, it'd be nice. So we'll just whip along here, and we'll hit the button outside because he moved it away from me, so I didn't click. Oh no, come back. Oh, get to the end. Oh, and I have no idea why Dot insists on like rescaling and moving things like hugely like that. That makes no sense to me. Yeah, fine. Oh God. Okay, come back. Now get over here. I don't know what happened there. Look at this. Add a little better. Why is he screwing around? No one knows. Good enough. Zoom in. What happened here? Well, okay, kind of ugly in the mix of things. Here's a call in the middle. There's a return. That's because this is a return to an I function here. And here's the call and call in, and they're in the middle because the layout doesn't know how to handle directly. But what he's really got going on here is the call and the call in. The call in has linked to the return of I, which is a function header. The double square bracket is a function header for I. who takes a parameter I and returns it immediately. So I to I just returns I. So the entire contents of the function I is this little space I'm trying to slowly move my cursor around.
Mhm.
Then the greater program has this while loop, has a fee function. The orange says function pointer. This fee function has an input, which is I to I, and the fee function has a back edge, which comes out of the null. If I can go find it here as a constant null, that's a constant on the back edge. So the type for this guy, we'll zoom in here. The type is function of int to int. It's number one function. It's the id function question mark. Its type is I am a question mark version of I to I. Here it says the type is I to I is a shortcut name because I know that you assigned it to a variable I to I. So as a debugging hint, I'll just tell you this function's I to I, but it's int arrow int pound one. It's the number one function of int arrow int, which is only once. It's the id function without the question mark. Here it is, same function with the question mark. Now you have a question mark there. That type came about because when I did my flow analysis, which is a peephole, it's just a standard type thing. I have a fee function. I mixed the null from the back edge, the fallen value. You do a meet in the lattice. The meet in the lattice says null meet function pointer. You get a question mark function pointer.
Mm-hmm.
Okay. Call says I cannot take question mark function pointers. That is an error. So when I'm done using my analysis, I go ask call, do you have any errors? I ask everybody, do you have any errors? Same for stores doing null pointers. Loads and stores are null pointers. Calls, same thing. They ask the question, is my pointer nullable? Oh, that's an error.
So our question marks can be proven that are not null by the end of the compilation?
By the end of the compilation, if you pass, there will be no question mark types into calls and loads and stores. Yes. That is how simple does the thing. It's just a straight up standard top down forward propagating flow analysis.
Mm-hmm. Okay. So it basically ensures that at runtime there are no values. There are no uninitialized values.
Right. By spec on how simple works, there's never an uninitialized value, but the initial value will be null in many cases. What instead I'll say here is there will be no null pointers passed into calls, loads, and stores.
Yes, yeah, that's more accurate. Yes.
Right, but there is an initial value.
Okay.
One other interesting oddball thing here is these gray $RPCs. And there's an optimization opportunity awaiting there that hasn't happened. Now, an RPC is a return program counter. And every call creates one to be passed in to the function pointer. So it's a fee function. There's a parameters of the okay, here's back up. Function headers, these square brackets. Here's main up here, and here's I to I here. Function headers extend region node. They merge all people who call them. So they're a merge point. And they have a default call until I do some sort of global call graph analysis to say that I know who can call you and who can't. Until then, I assume that anyone can call you, maybe your .o file, and you're going to get linked. The future compiled code yet to be seen at the link time will call you. I have no idea. So you have a default input, which will be the space of all possible returns for an RPC. And then a call in here will take in the return takes in can't hardly see the light blue brown line, the return pointer, and he passes it back. This is how you jump from a return to a call in. It's the same as a return address on an x86 stack where you do a return op. He grabs the pointer from the stack and jumps to it. It's a code jump. That's what it is here in the graph. So in the graph, return program counters are first-class citizens. They're first-class citizens in the typing system. That means at some future point, I could in fact do call CC analysis and optimizations. Call continuation, or totally have the framework in place to do call with continuation or tail call elimination optimization. That is a key piece of tail calls and call CC and those kind of things that I think a lot of people don't think about. Fine. There you go. So the viewer got extended to have return PCs. It got extended to handle orange function pointers. The type system picked up function pointers. I don't think I bumped the lattice. We include function pointers, but they are basically done identically to memory ops, except they have a signature instead of a pointer to a struct. They have a signature thing. It's otherwise completely the same kind of stuff. Chapter 18, docs. I know I had 2 lattice pieces in there, but I think the other one was like just exploring. Let me look. Yeah, I can throw this one up, but it doesn't help. This is the extended lattice for ints and pointers and everybody else, and then the giant one. Let me do the giant one. I think you've seen this before. Lattice.svg, yes. And come back over here, try this, see you. I'm gonna do that. Oh, there it is. Yeah, piece of cake. Somewhere here, pointers. Pointers have a pointer and a struct. Structs have some stuff, and they have a null or not the null. Function pointers have a null or not the null, just the same. Their struct bit is instead a signature, which is a tuple, just like a struct with name fields, except they don't have names on the tuples. It's just int, by float, by whatever, arrow to whatever. So they are almost identical to the layout you see for pointer to struct, except it's pointer to sig, more or less. The expectation on functions is that they are uniquely named and so uniquely numbered, and I have a bit set that counts them exactly, so I get a more precision. Whereas with structs, I expect to make another struct, another struct, another struct, another struct, so I don't try to track each individual struct you ever make. So function pointers have they have a bit set to count all the functions of the same signature you might be passing around. They have a little more precision than pointers, but that's it. All right. I think people are quiet. I'm gonna ask for anything else and then wrap it up here. 2 hours, brains fried, all done. Done. Okay.
So when do we start writing a standard library for this language?
I wouldn't mind. I think I wanted to do method pointers. So if you wanted to come in and add methods, I'll tell you how to go do it. It's a stupidly simple thing. You just define a function in a struct, and then a little syntax sugar. I have an example up in here that, where did it go? If I go find it here, this guy.
Don't you need some kind of self pointer?
Yeah, and then you get a self
Or
pointer.
do you just have, if you call a method that is on a struct, that you automatically pass the struct itself as the first parameter?
Yes, exactly. That is the only thing I'm doing here. Of course, I can't find a quick example just lying around. Here it is. Let me go.
So that was something I liked with Python, that the class functions just took self as the first argument. And in theory, you could name that whatever you wanted. Self was just the first argument.
Right. This is exactly what I'm doing, except that when you make the call, you'll get it passed by default. So here is a function f. So a field f is a normal field in that sense. It is a immutable function pointer. So this is a candidate for being a method call, an instance method call. And an implementation could take this field and haul it off to a prototype or a class for struct s and not actually include it in every instance because it's always a constant. It is a constant function. Every constant value in simple can be hauled off to the class, including function pointers. Here where you say s.x, s.f, I don't have it here. Okay, so s.f, like this. I would claim this is syntax sugar for passing f as the first hidden argument. And then, of course, you just put things in scope here. So if I have a float pi as a thing here, wherever this came from, I don't care what. And here I want to say return pi. Hiddenly, you would get a secret self, and you just extend the scope, so you don't have to actually do anything in the language to type it. And then this guy here is just going to pass you that. But that's all syntax sugar. So you don't actually see it when you write it. So you just write it like
So my
this.
question is, why don't you have to include the self?
Oh, because you want to
Like in
say,
Python, you actually have to have
yeah,
at
yeah.
least one parameter to put a function on a class.
It's how you want to write
Because
the language, how you want to define the language. This is all about convenience for the programmer. So I'm going to claim that I want to say, if you write a function that looks like some function pointer, so var or value, so it has to be a final function, compute is equal to, and you pass some arguments, A, B, C, arrow, and they have to be typed because, I need typed arguments. I'm not doing inferencing here. And float, I don't care what. And then you do something, A times B plus C. Okay, that's going to be times pi. That's going to be a candidate for an instance method. And only thing that means is I can call it with an s.compute, and I'll pass in the hidden s pointer, and it'll do what it does. And then I have to pass in A, B, and C because that's how I declared that function.
But
this means the function must be defined inside the struct.
Yeah.
If you hoisted that function definition above the struct and just said f equals.
Oh, I can get something else. So imagine you just said Java class here. You've defined functions inside. It's the same as Java here, right? Or C++. So there's no change in that sense from what people do. But I can also.
I have a question after that.
Yeah, let me do this one here. So I can do this. Okay.
Yeah, that's my question. In that case, it looks like it would not get bound to the struct.
It would not, and this would be a missing error. No pi in scope here. Right. So this is a compile time error, no pi in scope. So if I made a static function that didn't have a pi like this, I could do that. And then this again wouldn't bind self because it's given already what the signature is. Because it's given that signature, it doesn't bind to self, and there is no self being passed in. And so when you call compute down here, you wouldn't pass the self. And this is all sort of obviously available from just inspection of the signatures involved.
Yeah. So if I want to have a single struct that's got 1,000 functions on it, I do have to define them all kind of in one file.
Yes. If they want to include the structs as a hidden for free given scope thing, right? You can write the 1,000 functions anywhere and include them just like I did with frog, but then they don't get to use the struct s unless you make it explicit. And you just make a static function that takes an s. Okay, you do.
That's why that is
okay, and I can use the name s there.
Yeah.
So if you can declare a function, let's say compute is out of scope, but its first argument is self s, for example, and we can make this a extension method. So if C does maybe.
I wasn't going to allow that, and I hear that, and that's an interesting one. That's an interesting language spec question. So that question, let me go make an explicit one here. So somewhere out here, I call a new function frog, and it takes an s whose name is special itself.
Yes, maybe. Okay,
yeah,
let's say that.
And it takes some float f, and and as a function it does something. It takes self dot pi plus f, and that's what it is. Then the question is, can I call it like it's an instance method?
Yes, yeah.
As opposed to calling it like this.
Yeah. I believe C# has some syntactic, sure. Maybe most of the extension methods have something like that.
Right. And my argument is you can do that by convention, by just when you make your struct s, just have a lambda that passes in the struct.
What I don't want to do is...
Right. So add a new field that's val frog.
All right, let me back up. So what I don't want to do is have to pass in a self on an instance method and use the self keyword internally. I like the Java and C++ version where you just access it. It's part of the namespace.
We can deduce that as self is it's inside its own scope, and we can omit that.
Yeah, this one's here. I think that's okay. Then this one here as a extension method is an interesting question for me. I don't know. do I want to do this?
So
Right.
you
But you don't have to do that. I can do it myself. I can just say when I'm defining the struct
You don't
that
get
it's got a
this.
lambda in there and it passes S in.
the convenience is that you can define extension method after you had defined the struct S.
Yeah, I understand the convenience method. This is like extending the definition of S by a new
Yeah.
method,
Yeah.
where you call it this way,
Yeah.
and this under the hood
It will
is
mean
syntactic sugar for frog of S.
yes, yes. I believe most of the languages go that way.
Right. And that works only if frog is currently in scope and takes an S as its first parameter.
And I do an extension method thing where if you said s.frog, I'll say, oh, that's a field, it's a final field in somewhere, and it takes an S as a first parameter. This is a function pointer.
Yeah,
It
but
takes
when
an
you
S as a
pass,
first parameter.
yeah, when you pass S, you say dot frog, you have to ask the question.
And also this name is self.
Yes.
Then I allow this flipping
To be
and I
called
get,
like a method.
yeah, like a method.
Hmm.
And internally here, I could also say, oh, well, call compute, I'm sorry, self.compute.
Hmm.
1, 2, 3, then I'll deal with pi. I'll pick up pi. I'm going to call it compute.
Yeah.
And then the other thing I could do is I could call frog with some S and like this. This is the classic.
But if my struct has a frog field on it,
Right. And I want
you
to.
need a well-defined order of do I check
Yeah.
the struct first or do I check the extension methods in context
Yeah.
first?
Right. I claim that you would do.
Or is that a
S dot.
compiler error because they're both present? So no.
Right.
I
I
believe
would claim there's something.
there are multiple ways. There are multiple ways you can go about that. They can shadow each other's. Then you define what
I
shadowing.
would minimum say that s.frog wins. This frog wins.
Yeah.
And then the next is, can I reliably detect this as an error? And say you're shadowing, you're doing an extension over this.
Yeah.
The third option is I want to replace frog in S with my own version. I want to basically make a subclass.
Like an override. Like an override.
Yeah, an override.
Yeah,
I want to do a one-off override. In the land of Java, I would say, oh, well, class T extends S and it has a val frog, that is whatever it's going to be.
Right. So my question is, why do you want the syntax on line 260 instead of the syntax on line 263? Those seem identical to me.
This one is so it's intentionally clear. I am calling, it gives me namespace. First thing gives me namespace.
Yes.
Yeah, this frog is limited to the scope of S. So
I could have 6 frog functions defined in scope on different classes.
Yeah. Just so you do in Java. I have a class node. He has internally a class toString. I have 16 varieties of toStrings in region node and add node and float node and blah, 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 blah. So there's a lot of them. This is a scoping thing. And in fact, the way it's implemented right now is it's literally a field lookup. So it has all the same semantics and rules of a field lookup. So there's no special syntax, there's no special rules, there's nothing. It's just a field lookup. And if I want to get to a virtual call out of this, I can by just leaving it as a field lookup. As an optimization, because it's a compile time constant, I could inline that to an instance method as a fast thing. But if I had it as a variable field, it's just a field lookup. And if the field lookup returns me a function, it does, and I just call it. And oh, look, that's a virtual function call.
Interesting.
So I claim with no change to the model, I have this, other than the only thing I would need to add is if you say s dot final function pointer, I'm going to throw in the s as a free hidden extra argument, and then allow the namespace to pick up the local namespace things here.
Yeah.
And that will give you instance methods. So that's a thing I'm looking for to be added to the language at some point. Extensions methods like this look interesting. That goes into the experimental language feature realm. This looks like something I think makes sense, followed by having extension classes, subclasses, single inherited subclasses is the next thing. It should obvious thing. I'm going to implement what C++ and Java have implemented for 40 years, just because it's done. How does compiler do this? How does the runtime do this? This makes sense. Do I want to have extension methods also? No, that's an experiment. And then why this versus this? Because there's a namespace here, and I love the namespace. Don't get me wrong, I write these all the time. I don't want to go extend node with some little custom algorithm piece I need in some custom little guy, say static function foo takes a node, not node.foo, but foo takes a node. And then it takes a bit set for visit, and it takes an environment variable for blah, and it takes a thing I'm looking for, and yada, 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 whatever it's going to do. I didn't want to have it put in the base node class, so I kept it off to the side. So I write this code out here, the classic calls to frog. That happens all the time too. Is it useful to have an extension method on the spot? Maybe. I don't know.
It's just a convenience. It's just a convenience.
Yeah, no, yeah, right. So the convenience here is that the self call gives me the scope of a self without saying self in it. So I really want to say float plus pi, and under the hood have pi be self.pi. Like I look up pi in the local scope, I fail. Oh, I have a self argument. Go find pi in the self argument. Oh, you meant self.pi. Now I get an extension that I write this kind of thing, this style all the time, where I want to have it really local. I just want to have a local function, and I have a million no dot uses inside my local function, but it's a static function in some other class doing some fancy algorithm, but it says no dot, no dot, no dot, no dot. Wouldn't it be nice if I just skip the no dot and just derive node bits?
But wouldn't that make more checks? If you erase the self scope inside the function body, you have to discover which things are.
Yeah, you have ambiguity issues. You have to be careful with. Somewhere here, some guy comes along and says int pi equals 2.14. Oh, different version of pi. Return pi. Okay, now I claim ambiguity error or shadowing. Take your pick.
Yes. Yeah.
Yeah, I either report it as an error or a shadow. Shadowing's easy. I shadow all the time.
Yeah.
If you said int pi, you shadowed everything out of scope. Self is clearly out of scope. It would be as if this was running inside struct S, written inside struct S. So if I write a function in here, new function val foo is a function that does whatever. He says int pi equals 2.14. I just shadowed my outer pi, right? No problem.
Yeah, the shadowing's fine.
Okay, so there's an obvious semantics for shadowing, which says this is okay. I'm just going to shadow.
Yeah, the use case I'm picturing is something that smells like you have an iterator interface that's just, you have a function called next.
Hang on.
And it's a super small, super tiny interface.
I'm going to take all this writing, and we lost the history of it, but I'm going to move it to the doc because this is in my test case in simple, and it needs to be in the doc. So I got to do a thing here.
So you could imagine having a very small iterator interface that's just .next. And then someone wants to write a package that's itertools. And they've implemented count and toVector and reverse and a whole bunch of different functions that all operate on stuff that implements the iterator interface.
Yes. Yeah, I don't have interfaces right now.
It can be nice to have a syntax where I'm just like, hey, import itertools. And now my object that was an iterator now is also a reverser and a counter and all these things that were my itertools.
The Java syntax looks for an iterator interface, but he only gives you the colon. He doesn't give you the reverse and the this and the that, but he syntactically sugars his way along to there. So
but a lot of that stuff doesn't need to live on iterator. That stuff could totally live in some itertools package, but only if you have a way to extend classes that already exist by saying, hey, because this has a .next, I'm going to give you all this other stuff.
Yes, but you have to, well, I don't have a way for you to say, because it has a .next, you'd have to say, go extend this thing. But I don't have interfaces and iterators, so maybe that's a question for another time. But the whole extension method thing kind of like just noodle around in my brain like, huh, that's kind of nice looking. I would certainly write that code. I would use that. If I had that feature in Java, I would use that feature.
Yeah.
That's my bare minimum metric for language features. Would I use it? Oh, I do something very similar now. It would make my code a little nicer to read.
They become more convenient if you have to add the methods after you define somewhere something else, something in some other library, if you will.
Yeah.
They became much more handy. But this is nice because
here's another syntax that I could take. The name is dot.
dots. Yeah, that's fine too. You can take underscore. You can take something unambiguous.
Yeah.
Well, kind of like dot because dot sort of implies
import
the explosion of every single value that was in this class is now a value in my namespace.
Every S.
It's like an import. It's like import all the contents of S inside.
There's another one.
It's using.
Using too,
yeah. The splat operator also kind of works.
Yeah, exactly. Something. Okay. All right. So extension methods may be a thing of the future. Who knows? But I want instance method syntax sugar, and would be lovely if somebody wants to go doing it. But I'm going to do cogen first. And if it's syntax sugar, then cogen is totally unimpacted by adding instance methods later. So that's the first half trick. The other half trick is virtual calls actually need a little more love, but they'll almost completely fall into the category of no backend cogen issue at all, other than there's the table that you want to get laid out. But that has a different trick to it. That one's not too hard either. Fine. Cool. This is tutorial how to do this shit. But I do like your extension method. That's a new one for me. I mean, I've seen it before, but not like.
I believe C# does this way. If you declare the first argument like self something or this dot something or this dot s or something, it will allow you to call it like an extension method.
I'm using self just to distance myself from Java, so it's I'm trying to not.
Self is nice, dot is nice, underscore is nice. Anything that is. Yeah.
Okay.
I worked for a while with a form validation package that actually added a whole bunch of validators to the string class. And it's like right here when I imported my validator, I want my string class to have a dot, is email address, is social security number, is domain name. I certainly don't want to add those things to my string class always.
Yes.
So you can extend string though.
Yeah, you might want something that you don't want it all imported all the time, all the way anywhere, and it's something special, like you just mentioned, Aaron. That's
for me on the extension
right. And if I don't have that, I end up with the same thing over and over again in my code. That's validator dot is email address, pass in string. Validator dot is domain name is string.
Yes.
I would say that's Java said you can't extend strings, but if you'd extended a string, you would add those features to the extended string. I have a validatable string, and then I would just say.
Right. That's when I like extensions. I want to say, here is this package that adds a whole bunch of functions to this type, but only in the scope where I have this import.
Right. I want to be done, but I have certainly plenty of test cases where I will make a local complicated function like frog here that'll do something fancy schmancy, but it's completely localized to this file because it does a thing that's private static function, takes a node, and then.
But still feels like it naturally belongs on a class.
Yeah, it feels like it belongs to the node class, but it's private static to this file because it's doing a thing. I'm computing immediate dominator trees. I'm computing blah, blah, blah.
That's where I want my class extensions.
Right. I want to see if I could find an easy, I have lying around a bit of code here. Where's I should quit.
And again, you can always do that by just having a class for which every function takes some other class as its first argument. But
no, I don't.
Yeah, that's kind of Scala goes that way and goes overboard with this. In Scala 2, Scala 3 works in different way to introduce extensions, but it's essentially that idea. A class that it takes itself as something that can be imported into, and they go overboard with this.
Is this a good example? One of these is going to be a good example. Here, yeah, here's a reasonable example. Here is maybe a better one. In dot node. Yeah, here's a reasonable example. I'm gonna put it here in docs. It's too big, not too big. Something, oh, and the formatting got lost. So schedule early. Let me see if I hit extensions, I get color coding. Code blocks, start. Neat. Format. Can't insert here. Oh, color coding. Look at that. Okay. Node in and a bit set. If in is null or I've in.node ID, I'm out of here. Assert in, visits in node ID, in.inputs, do a recursive thing. If in is pinned, if in.in of I and in.in of I and in.in of I and in.setDef. So there's like 8 in dots in there, maybe 10. And it's completely specialized to global code motion. It does not belong anywhere except inside a global code motion algorithm file. But kind of would be nice to not say in.in.in.in.in.in.
Another way around that, if you allow to Scala allows to import n._, and all these things will do the same.
Yes, there's some sort of importy thing. But I only want it for this function. Because that file has a bunch of other algorithms that not all make sense.
Inside the function, that's the first. That's the first
line.
Yes, import n._.
Or in
and that would import, that would do the same thing.
Right.
Yeah.
Yeah, right.
That's
I like the name itself and walk away from it a whole lot.
That would allow you to extend it after the fact, but here you have to import it. You have to do something different that would achieve the same effect.
Right. I'm saying if I came up here and renamed this guy to self, or the special name, the underscore name, it would give me a free.
It will automatically import them. So the same.
Yep.
Okay.
Same thing. Yep. Okay. All right. Well, I'm gonna be done.
Cool.
That was a good thinking for me to noodle on. But Cogen first.
I was gonna say, how generic can that be? If you add in the same way that you could put dot as the name that you imported something as, you could also have, I can write the line of code that is just dot equals and then put something on the right side of the equals. And because I set dot to it, what I meant was exploded into my namespace.
You have to have an L value that has subparts that can be exploded.
You have to something that you have to import into.
Yeah.
That's how I would interpret.
He's saying namespace explosion. So I have some syntax.
I have some kind of struct. I say dot equals my struct.
All right.
And what I mean is explode the struct and put all of its names into my namespace.
Let me show you where
I think that's C#'s using keyword.
It's the node thing gets exploded here.
Right.
Node
so if I say dot equals n.
Yeah, not in, because in will never be used again. It's node gets exploded under this definition. So that would be some dot equals node.
Why not n?
Because
n is the thing that's an actual instance of a class.
In's the this pointer. I hear you, but in becomes the this pointer in this code. So why do I need the name in anywhere? Do I want it as a second or third argument?
No, I'm saying it should be equivalent. If I say node dot, that should be the same as saying node equals n, and on the next line saying dot equals n.
It would be only interesting if I had another name here.
I'm just trying to make it less specialized to like I'm in the middle of a call. To just say generically, if I'm binding to a name and the name that I'm binding to is dot, what I mean is explode this into my name. Explode this namespace into my namespace.
Here I'll get what I'm hearing you saying is I have a syntax that lets me keep exploding things out to be default imported.
And in this case, if something was in both n and visit, n probably got shadowed by visit.
Yes, and I have used these languages as well, and those were a nightmare for the shadowing. And then there was a version that I used that just said they conflict. And then I got used to saying, oh, I could always import visit and I could always import node, but I couldn't import both visit and node because they had some stupid conflict of thing I never cared about.
And that you renamed the import.
Unless I renamed the import, and then it lost the point. The point was I was going to say in.things and know that I was referring to like under inputs and node ID and set def and all these things were all just short, quick names. Except I had a node get. And then I had a bit set.
Because my example is I want this to be what I want this to be is a special case of tuple unpacking.
Yeah, I hear you. And I'm like twitch. That's too much tuple unpacking.
So if I know that I need a specific thing, instead of saying dot equals n, I would say open parentheses.
Tell you what.
In and nis and set def.
Aaron, you hand me a pull request with the changes, and I'll take a look at it.
That would be an unambiguous way to suggest it, I suppose. No, that's a totally fair response.
Uh-huh. I have my
and with that, happy lunching.
I want to do, and other people have their things that they want to do. And if you send me a PR, I will certainly take a look. But by the time we have, we don't have a large enough code base to matter. So if there were a larger code base to show up, say, some standard library things like a string class, then, that would be, so after, method calls, there'll come a string class. I'll fold ints and I'll fold structs and arrays together. And the obvious C way, you have a trailing array on any struct. That one's served straight up. And then add instance methods. Now we can do strings. After that's done, I might start looking at other things that you might want to go do, like extension functions for strings and inheritance and whatever, subclassing, blah. There's 1,000 things. So not yet. And I think that was my wife telling me to go help her because she came home with the trash cans. So it's time for me to bail.
Okay.
Thank you all.
Yeah, it's fun.
Bye.
Bye-bye.